There are discoveries that completely reshape our understanding of astronomy. Others leave scientists puzzled for years. And then there are the discoveries so extraordinary that they shake the very foundations of modern physics. These are the kinds of observations that leave Nobel Prize-winning researchers struggling for words, that cause cosmologists to question decades of accepted theory, and that force even the strongest supporters of the Big Bang model to admit that something doesn't add up. That is exactly what the James Webb Space Telescope has done. For the first time in history, humanity has looked farther into the universe than ever before, reaching back toward the era when the very first stars and galaxies were expected to emerge. According to everything we thought we knew, Webb should have found tiny, faint, immature galaxies slowly assembling from enormous clouds of hydrogen gas. Instead, it uncovered something no one was prepared to see. It found enormous, brilliantly luminous structures that appear far too massive and far too organized to exist so early in cosmic history. These objects look as though they belong to a universe nearly 1 billion years older than the one they supposedly inhabit. They are not behaving like young galaxies, they are not growing the way current theories predict, and in some cases they may not even belong to the category of galaxies at all. With every new observation, another piece of our cosmological model seemed to fall apart. One surprising discovery followed another until a quiet realization spread throughout the scientific community. James Webb wasn't simply discovering new objects. It was exposing serious cracks in our understanding of the universe itself. Everything began with what looked like an ordinary yellow speck hidden inside one of Webb's deep field images. Among thousands of distant points of light, nothing about it immediately attracted attention. But as astronomers studied the data more carefully, one feature refused to fit any existing model. It was astonishingly bright. Not slightly brighter than expected, but so luminous that it challenged every prediction about how galaxies should appear in the early universe. At first, scientists assumed the explanation was simple. Perhaps the object was much closer than they initially believed. Distance estimates can occasionally be misleading when observing unimaginably remote regions of space. Then spectroscopy provided the answer. The object's enormous redshift confirmed its incredible distance beyond any doubt. Suddenly researchers realized they were looking at one of the most distant galaxies ever observed, existing when the universe was only a few 100 million years old. But nothing about it resembled a young galaxy. Instead of appearing small, irregular, and still under construction, it looked mature, compact, and remarkably well organized. It seemed like a fully developed system existing during an era when galaxies should have been taking only their first steps. That was the moment concern quietly spread among astronomers. Because if even one galaxy had evolved that quickly, then something fundamental in our understanding of cosmic evolution had to be wrong. Within days, Webb revealed that this mysterious object was not unique. More and more distant structures began appearing throughout its observations. Each one challenged another prediction. Each one contradicted another expectation. And together they painted a picture of an early universe unlike anything modern cosmology had anticipated. The deepest images captured by James Webb were expected to reveal cosmic infancy, small, dim collections of newly forming stars scattered across the darkness. Instead, Webb found activity. It found complexity. It found enormous numbers of bright, compact systems that appeared surprisingly mature. Thousands of unusual objects filled these ancient regions of space. The more researchers examined them, the stranger they became. They were too massive. Too bright. Too organized. Too compact. Nothing about them resembled the primitive galaxies predicted by standard cosmological models. Even more surprising was their abundance. These weren't isolated exceptions hidden among billions of ordinary galaxies. They appeared throughout the earliest observable universe. Recent analyses identified dozens of candidate galaxies dating to only a few 100 million years after the Big Bang, far more than existing models can comfortably explain. Several researchers openly admitted that if even a fraction of these observations are confirmed, our understanding of galaxy formation will require major revision. That realization is perhaps the most unsettling of all. Instead of revealing a universe slowly building itself over immense stretches of time, Webb appears to be showing the cosmos that reached maturity far earlier than anyone believed possible. It almost looks as though the universe skipped its earliest stages altogether. And that possibility continues to challenge some of the most fundamental assumptions in modern astronomy.